Chapter 2, Rolling Stock. 2.1, the first railway car was merely horse-drawn wagons. They were introduced in England in 1602, transports a load of coal in English mines and navigable streams where coal was transferred vessels with wagons equipped with the handbrakes to reduce their speed. With the started rolling faster than the gait of the horses, then that pulled they had Holden wheels rolled in wooden wagons on ways of rails called tramways. The experience also proved the wooden wheels and rails more quickly had to be replaced frequently. This led to metal wheels and rail wheels. But as time passed, industry grew limited capabilities. Horse wagons could not meet the demands of transportation. Every increasing tonnage, some method of transportation was needed that they both carry heavier loads withstand long use. When steam locomotive was built to replace the horse, the wagon roadways, iron rails, later steel one was developed. Railway cars were designed built to replace the horse-drawn wagons. The original railway car was constructed to hand minimum loads of locomotive beds and truck structures. Through these years, the roads and structures have been improved. The equipment more efficient, larger, heavier, stronger, safer. The railroad's private car owners include Army now own and operate heavy-duty railway fleet. Today's piggyback flexi van car can provide a high degree of flexibility, minimize empty car movements for the return trips. Containers expanding continually being used increasingly, while the containers of the flat car becomes all-purpose car. The advantage of the fast loading, unloading, freight handling labor is reduced. Damage to the lading is decreased. The chapter describes some of the rail equipment is the Army zones emphasizes placing foreign services knockdown fleet that can be used for theater operation anywhere in the world. The charge chapter also discusses the freight car passenger special equipment. Recently developed rail cars which may improve to be desirable in transportation of nuclear weapons. 2.2 Rolling stock. Railway rolling stock is classified in four general types: house cars, open top cars, flat cars, tanker cars. All railway cars except for flat cars are six general components: truck, spare gear, draft gear, couplers, underframe, superstructure. And since flat cars have no superstructure, they have only five components. The following subparagraph discusses each four types of cars in order and mentioned. House car have enclosed superstructure with sides and end of the roof, usually doors, vents, ladders, rooftop running boards. Boxcar, refrigerator car, cabooses are examples. Since boxcar refrigerator cars are discussed in 2.13 and 2.19, only cabooses are described here. A caboose is a car attached to the rear of the train. It accommodates the conductor. Flagman serves as their office of quarters, and in transit, the caboose also carries and supplies tools and car parts that may be required en route. B. Open top cars such as gondolas, ballast cars, hoppers normally have sides and ends, and however the both type of the hopper cars converted to open top are included in an open top category. The following subparagraphs describe two types of hoppers and ballasts. The gondola is disguised in paragraph 2.2. The cover hopper is permanently increased, the weather tight and within the fixed sides of the end roofs. Opening the weather tight covers and doors, and providing the roof and the other sides which the cars loaded, and for unloading the cars may open in the bottom of the tight of the fitting covers, doors, ports, valves, and roof sides. Opening with the freight may be discharged, covered in hopper partition in compartments. Open hoppers are similar to gondolas except for they higher end sides ends, generally exterior self-cleaning. For example, sloping construction of the car's bottom of the compartments at the end of the openings equipped with a door, provided the discharge cars can contain contents. Open hopper cars are many types of varying according to the size and class and commodities. Some type twin hopper pockets will other have quadruple ones. Each one has a door of discharging lading. Ballast cars are similar with low side gondolas, except for the may be loaded discharge from the side, sometimes referred to as side dumping gondolas. These cars are used as hauling ballast, sand, gravel, small loads of coal. Flat cars are no housing body for the simply a floor lading over the underframe. Still, the low capacity, the flat cars range from 50 to 250. Examples are basic flat car, the depressed center one that's described in the further in paragraph 211 and 218. Tanker cars are those with tanks mounted on special underframes. They carry many kinds of liquid, semi-liquid commodities ranging from milk to TNT. Interstate Commerce Commission issued regulation specifications governing tank. The United States, these specifications are combined with the Association of American Railroads to make one of the specifications covering the car instruction of the ICC publishes for overseas use specification and modified because of the emergency Austria demands. 2.3. Freight equipment of the military use. For instance, the railway cars being used in military purposes occurring during the Civil War when motors and permanently mounted on railway flat cars moved into the area. Supported troops in 1917. Five naval batteries were built and shipped to France for use of the World War I campaigns. Each battery consisted of a gunner car carrying about 14-inch guns, an ammunition workshop, kitchen, berthing cars, and 14 cars of each battery were probably the first railway cars used in entering the military service. Army railway motive power, the rolling stock built for the use of domestic service, differed from the little in design for the standard use of commercial railway equipment. In the comparison for the foreign equipment, however, the general leverage and heavier in World War II began in European rolling stock. It had small carrying capacity, was scarce of all theaters in operation. Many cars were hurried and designed and built in the United States, shipped overseas, and knocked down to save shipping space. A few American cars were modified for use of the European railroads. This experience led to development of railway fleet capable of operating in the railroads various gauges, which can be sent to the quick as to the areas of conflict. Some of the equipment can be shipped knocked down to conserve shipping space, since one describes the knockdown equipment. Section 1 Knockdown Fleet 2-4. The experience of World War I and World War II showed that the foreign railway system is incapable of sustaining combat operations because of the capacity and the amount of the foreign railway were not enough for military purposes. The use of the Army realized it had been prepared to produce its own motive power. Rolling stock should be engaging any enemy foreign soil. Soon after World War II, the Army began to develop railway feet suitable for use in the future of the theater operations. The objective for the railway car was to modify the American car design capable of operating in a foreign country, and the train with local equipment, starting with a basic flat car that could be converted to a gondola, boxcar. Additional for the proper structure of these cars were to design with the coupling and braking system and equipment used on principal railroads, foreign countries, and onto the capable operating on the railroads of the various gauges. Keeping in mind that these equipment, the American designers developed a basic flat car. In addition, with the domestic service equipment, the Army inventory contains a knockdown fleet of 40-ton equipment designed built primarily for emergency overseas service. Another one used for the narrow gauge track in the foreign theater was proposed but not procured. It was consistent of 76-ton diesel electric locomotive, 30-ton gondolas, 30-ton flat cars, and 55 depressed center cars. 40-ton fleet consists of more than 11,000 items of motive power, rolling stock, and storage of the various item depots. Instructions. Paragraph 2.5 through 2.10 discusses the general construction of major components of the cars of the foreign services fleet and the procedure for assembling knockdowns. These remainder of the section accompanying the figures describe the cars of the fleet and can be assembled or partially assembled in the theater, explaining their assembly and conversion. 2.5. Because of the because of the accepted shorter life of the emergency equipment used in the theater operations compared with the standard equipment, the fleet is constructed simply economically as the military standards should permit. Designers for the equipment found on the physical characteristics of foreign railroads with limited capacity dimension. For example, the track bridge load limits were determined the equipment's axle load, while the clearance would affect its dimension. The designers decided that the capacity of 40 tons was best. Transportation military supplies equipment, each of one standard to broad gauge 56.5 inch, 60, 63, and 66 inches. Design modifications were based on the equipment's shorter life expectancy of regulations expected to govern the rail operations in the theater. Emergency overseas equipment is designed to build to meet the clearance limitation of foreign railroads. The major assembly components, different types of knockdown cars are interchangeable. Paragraph 2.6 through 2.9 discusses for the basic components of the railway cars of the knockdown fleet, with the exception of the tanker cars. Paragraph 2.10 discusses their assembly. 2.6 trucks. Multiple gauge trucks were enabled the knockdown fleet to operate the railroads on various width through those width standards of the broad gauges. The trucks can be adapted to the different gauges, and an entire truck might be removed or another substituted, changing in the gauge of the wheels. When once was multiple gauge trucks can be accomplished only by a general support maintenance unit. Wheels cannot be pushed in or out at will, and heavy duty wheel compress is required. The multi-gauge truck can be applied to the locomotive wrecker and locomotive cranes, snowplows, and other railway equipment. Trucks, wheels, and used equipment to the fleet conform the standards of Association of American Railroads and are completely interchangeable among the cars of some capacity. Only the major assembly, however, that are interchangeable among the trucks themselves. A diagram of the typical railway truck is shown in Figure 2.1. 2.7. Because of the fleet is designed primarily for the services in overseas area, it is equipped with a hook and link coupler, the predominantly Europe and Russian and other parts of Asia. The inserted sketch shows the hook and the link and the coupler as well as the bumpers for absorbing jolts. Figure is modeled of the car equipped with a hook and link and coupler and bumpers. The equipment of the fleet is designed so that it can also standard automatic using standard automatic U.S. coupler. Here you see a side bearing, axle, center plate, brake lever, brake hanger, brake shoe, wheel rail, brake beam, brake pin, bottom connecting rod, journal box, side frame, spring plane, coil spring, and bolster. 2-3 understanding for underframes. Equipment for the fleet using steel underframes, complete fabricated, drilled in car builder shop in the United States. All underframes for the flat cars, gondolas, box cars are assembled in the same way. Wooden plank flooring is laid over the underframe. The 2-9 superstructure, made generally in the wood, metal reinforcement bars and superstructure units provide only rigidity. They are not designed to support applicable amount of the weight of the lading. Superstructure units are prefabricated, punched and drilled for the rapid assembly. 210 assembly. The general method of assembling a car of knockdown fleet, with the exception of tanker car, files the first assemble the trucks under the frame. These install all miscellaneous items of the underframe, including the air brake equipment applies to the underframe's end sills and such a part as coupling, drafting gear, buffers, and blocks. Next moment, the underframe assembly to the trucks. Lastly, the attach to body side bearings, shims, wear plate to the body bolsters. When required, add the proper superstructure. The components used. The components of unassembled cars are packaged in quantities that permit the issue of the cars in multiples of 10 components common to all cars that are packaged separately from these particular type of one type of car. 211 flat car. Known as the workhorse railway service, a flat car is used to transport very large and very heavy items. The basic unit of the knockdown fleet is a flat car. It simply is a flat floor laid over the underframe sills and placed on the trucks. It has no housing or body and shows major components of the flat car figured in 14. Figure 2.3, components of assembling a flat car, shows the car after the assembly. Flat cars of the knockdown fleet are structurally designed for the load capacities of 40 tons. In addition to serving as regular flat cars, the 40-ton cars also provide a foundation which the superstructure unit can be added to the convert them into gondolas and box cars. Underframes for the flat cars of 40-ton fleet are shipped to the wooden floor already laid. Flat car underframes are completed interchangeable with any other car of the fleet. The side and the end sills of the flat car are prefabricated, punched, and drilled. In the theater of the flat car is generally used for very early rail operation. When the theater activity stabilizes, any requirements increase the transportation of supplies. They need protection from the weather pilferage. The flat car can be covered and closed after a conversion. The weight of the landing is still carried by the car bed. The superstructure provides rigidity, not support, because of the versatility of the flat cars in the backbone of the fleet. 212 the gondola. By addition of the sides and ends, the basic flat car becomes a gondola, either high side 48 inches, low side 18 inches. Gondolas may be assembled depending on the height of the desired. The only difference in which the two cars is the height of the superstructure. This shows a flat car being converted into a high-sided gondola. Figure 2.6 shows that after assembly, their side of the end of the gondolas, the knockdown fleet made of 1 and 1.5 inch tongue and groove wood. So sheeting of the metal reinforcement bars may be used on 40-ton flat car underframes with minor adjustments to corner bands and ends. Version of a flat car to a gondola consists in generally positioned sides of the underframe side gondolas, securing them into the place, fastening handholds position, and assembling, securing corner posts and on all corners of the car. Gondolas can transport a variety of the heavy local items. They are used primarily for carrying such materials as coal, ore, stone, lumber, iron, steel products, machinery. If necessary, they can be used to transport troops. I'll get it. 213 boxcars. Included with the side engines of having a roof, the boxcar is designed to carry the commodities that must be protected against breakage, pilferage, weather damage. Like the gondola, boxcar of the knockdown fleet can be assembled by adding the proper superstructure to the flat car underframe. Made of light frame plywood lining, the superstructure consists mainly of side ends, doors, and roof. The sides are constructed in 4 separate sections, two for each side. The ends are single units. The roof is 1 unit. The door assembly consists of door track, threshold, plate, and door. Figure 2.7 shows the flat car underframe of the boxcar superstructure unassembled and shows the assembled boxcar with the door open. To assemble the car, the underframe is assembled the same as the flat car, exception of the camber adjustment, the corner connection angles, and sill step handholds. The two side sections adjacent to one of the end of the car are first attached to the underframe. The end of the unit connecting the two of the side sections is attached to them. The end sill of the underframe. The same procedure followed for each other end of the car. When the side sections and the end of the units are erected with the door track, the doors are either in proper place or the roof is positioned secured to the corners and sides. 214. A tanker car consists of a tank usually made of steel mounted on one car with a special underframe, except for the superstructure as modified underframe. The tank car has a component similar to the other cars. The underframe is floored and steel running boards are built on either sides of the height, even into the floor, made of corrosion-resistant material. The tank shells may have either a single compartment or the multiple ones. The ordinary tank car has a single compartment equipped with dome, safety valves, and bottom outlets. To prevent corrosion, linings are required to be in steel tanks when acid has shipped in them, so may be insulated to provide even the temperature required by certain commodities. In addition, some cars may have steam coils installed inside the tank's shell to provide heat for lading. Tanker cars are used for transporting liquid, semi-liquid commodities such as oil, gasoline, alcohol, acid, coal tar products, compressed gases, fruit juices, and milk. Tank capacities usually range from 5,000 to 10,000 gallons. A typical U.S. Army tanker car is shown in Figure 2.9. Tanker cars in foreign service fleet shall have the single compartments would normally carry the petroleum products. The 5,000-gallon car operates narrow gauge railroad roads, while the 10,000-gallon one runs on the standard to broad rate gauge tracks. The car manufacturer assembles the tank unit to the car underframe along with the outlet of the safety valve by assembly. Dome car over the remaining work of it can be done in the field. It consists of an assembly applying the following subcenter still and center plate to the plate of the tank underframe, assembly tank underframe, assembly to the trucks, the miscellaneous items such as brake equipment, supports to the underframe, parts to the sill, air brake of the underframe, the body side bearings, shims, and weared plate, the body bolster, such miscellaneous items as tanker ladder, braces to the tanker car body and tank. 215. The summary. Experience in World War II provided the Army must prepare to supply its own locomotive and railway cars in theater operations, since the more foreign countries have just enough rail equipment to support their own needs. The military tonnage requirements placed on the railway system would not only exceed the capabilities of their equipment in the facilities, but also create near chaos in their operation. Therefore, to meet the emergency, the U.S. Army inventory contains a fleet of railway equipment specially designed and built for the use in theaters and operations where standards to broad gauge railroads are operated. In developing the foreign service equipment, the designers would physically characteristic of foreign railroads would influence size capacity. They decided that the capacity of a 30-ton was best for the equipment that would operate on narrow gauge railroads. 40 tons for equipment operating on standard to broad gauge. However, only 40-ton fleet was procedure. The cars were fabricated and punch drilled in car builders' shops to provide for easily assembly in either theater, and they could be shipped, knocked down to conserve shipping space. Major components assembly and are interchangeable with minimum modification to coupling arrangement by substituting trucks, altering trucks to fit different gauges, and the 40-ton equipment can be operated on the frame can operate on from the standard to broad gauge tracking ranging 56.5 inches to 66 inches. The flat car's basic unit of the knockdown fleet can serve as a regular flat car during the early theater operations when the theater activities stabilizes other types of cars are needed. The flat car can be converted into the field of gondola and boxcar. Gondolas can be assembled by adding sides or ends to the flat car depending on the height of the desired, either the high or low side of the gondola. May be erected. With cars that are needed to carry commodities requiring protection from the weather and pilfers, the flat car can be converted into a boxcar, additional sides, end doors, and roof. After the flat car has been converted either to a gondola or a boxcar, the weight of the lading is still carried on the bed of the car. Superstructures and units provide the rigidity but not support any appreciable amount of the weight. Tanker cars of the fleet are particularly assembled by the car manufacturer who attaches the tank unit to the car underframe along with the outlet, safety valve, assembles, dome, coverage. The remaining assembly can be done in the field. Section 2, other equipment general. In addition to the knockdown cars described in paragraph 211 and 214, some heavier freight cars, some passenger cars, some equipment built for the special purposes, including the foreign service fleet in the section discussed in the rolling stock, in addition with some of today's newer developments in railway equipment. 217, 80-ton flat car. Some of the 80-ton flat cars are included in the overseas fleet. An example for carrying ordnances, energy, and engineering equipment weighing more than 40 tons. An example is in Figure 210. Similar 40-ton flat cars. Only larger these cars are designed to meet the most railway operating restrictions in a theater. They are shipped knocked down and are packed for easily assemble. However, the converting them to a gondola or boxcar is not planned for at the present because there are greater load capacities in each car that is mounted on the two wheels for two six-wheel trucks, three axles per truck to avoid exceeding the low axle limit of the foreign railway truck, bridges, and other railway structures which are designed to support a certain amount of weight per axle. With six-wheel trucks, weight is distributed evenly over the greater area. Within four-wheel truck, more weight can be supported. The 80-ton flat car is designed to operate in standard to broad gauge railroads. 218. The flat depressed center flatbed. The flat car's lower depressed centers have been designed and built in transportation ordinances, engineering material equipment that would be exceed a permissible height if loaded on a regular flat car. The usefulness is measured mainly by the added headroom, and they afford for clearance. The 70-ton depressed center flat car designed on a foreign service has two six-wheel trucks as shown in figure 211. Operates one from the standard to broad gauge track 56.5 to 66 inches. 219. The refrigerator car. The refrigeration is the most important moving perishable items, and controlling the temperature is essential to protecting such foods as fresh fruit and vegetables from freezing transit. Refrigerator cars can be used in both purposes to bodies to cool and protect them from too much cold. A car can be cooled with ice or mechanically means. Standard refrigerator car reassembles box cars in general outward appearance, the framework, sheathing, endings, roof, and are similar to those in use in the standard boxcar construction, except for the installation has been added. And in an ice-cold refrigerator cars, the roof has a hatching openings with the ice is loaded. Figure 212 the shows a refrigerator car with hatches visible. The refrigerator car developed for the Foreign Service Fleet, 40-ton, 80-wheel ice cars. They have same type of the underframe trucks, brake coupler arrangement as the other cars of the Foreign Service Fleet. Superstructure outside of the sheathing of the plywood, two ice bunkers are installed, one at each end of the car to receive the ice from the hatch opening. Hinged metal racks that are placed over the floor. The side ends of the roof and the floor are insulated with fiberglass. 220. The passenger equipment. Ambulance train cars are only passenger equipment included with the Foreign Services Fleet. Because of the experience of the Army Medical Services during Korean and Vietnam Wars, the rapid development of the air transportation, quick evacuation of the wounded from the combat for the requirement of the rail hospital cars in the theater is not as great as years ago. However, the ambulance provide temporary facility to care for the sick and wounded patients whilst transporting them to central points where they can be evacuated by air to VA-based hospitals. After World War II, the Surgeon General requested that the ambulance train consist of three types of cars. The cars of ward, a medical and personal, and a kitchen dining storage car. The design developed for use of the foreign railways with standard and broad gauges. The cars were to have common underframe superstructure designed for the interior arrangement fixtures appropriate to each type of three-car prototype train was designed and constructed and has been placed into storage. The cars of ambulance trains are constructed out of steel. They are interchangeable under train frame and superstructures components. They are built to resist the greater impact forces, providing maximum safety and comfort. They have multiple gauge four-wheel passenger type trucks. The coupler arrangement is designed to permit rapid conversion and other coupling arrangements of the standard to the broad gauge trains, but each car is insulated, ventilated, and equipped with its own heating power generated plants and water supply system. Only the ward cars, air conditioned car windows, are designed for the complete blackout. Three cars of the train are designed to operate as a unit and are furnished complete of the railway ambulance facility. Each type of the car is discussed in the following subparagraph. A ward car is located on the midway on the both sides of the center aisle. The ward car is the Terrier type of the bunks, accommodated with 30 litter patients, 12 litters, and 24 ambulant patients. 6 bunks are stationary. 24 bunks can be converted to seats. Other facilities necessary for the patient comfort and care including sterilizing equipment, laboratory, and air conditioning system. A receiving room and located into the platform, sliding side door provided for the receiving of the patients in the car. B. The medical personnel of Army Medical Services are provided with the sleeping quarters, dressing rooms, and toilet facilities. The medical personnel car is equipped with 2 air circulating blower units. This contains a stateroom and 4 officers, 2 nurses, and 15 enlisted men. Kitchen dining storage car, a space for storing medical food supplies and the preparing of the serving food is contained in the kitchen dining storage car. The car is divided into 3 sections. The kitchen, which is cooking, is stove, refrigerator, steam tables, bins to prepare complete metals. A dining area with table to seat 24. A cleaning area containing the service sink, storage space for medical food and cleaning supplies. car also has an emergency water supply. Who-21 Special Equipment Jerusalem. The time required for the various types of rail operations, speed up repairs, laboring, saving machine tools are provided as special equipment designed for specific purposes. Has built the U.S. railway operations. Two types of such as equipment such as using Forest Services fleets, cranes and snowplows. Cranes are in unloading cars moving supply materials. Cranes help to speed up many of the railway operations, clearing railway lines when traffic has been interrupted. Washout of land slides, wrecks, and other causes. In one of the main tasks is when the cranes can be caused. The cranes and Foreign Service fleet can be especially useful in handling very heavy trucks, assemblies, bulky superstructure units, and erecting cars of the knockdown fleet. In Figure 213 shows the crane in use. Snow handling equipment. Clearing the snow and ice from the railway tracks is important, keeping the railway in operation of the severe weather. The snow handling equipment in the Foreign Service fleet is a year-round multiple service track maintenance machine. In addition to clearing ice snow from the tracks during the winter, this snowplow also can be a spreader and ditcher car and can also be used in other seasons of the year to do a variety of jobs. Some of them include spreading dirt, leveling ballast, ditching and forming slopes, banks, moving dirt, filling material, widening road beds and cutting building and reinforcement road beds, removing the four ballasts from the ends of the tie, and sketch up the spreader ditcher as inserted below. 222 Special Railway Cars. Some of our Army's highly refined weapon systems such as missiles, rockets, and nuclear warheads pose special transportation problems because of their size sensitivity. While in the transit, those weapons may be damaged for the high handling environment, the convenience of itself, and therefore a special car must be taken in moving by and protecting them. One of the more recently developed railway cars is designed for both piggyback container and container services. Is equipped with a short absorbing mechanism that provides a high degree of protection for the equipment landing, and shows Figure 214 three basic elements of a container, the trailer chassis, and the piggyback railroad car itself. The following subparagraph discusses this equipment. A container is specifically designed for the ability to operate interchangeable between the road and rail and ship. The container is key to the item of the containerization transportation. It can be used in lifting, lift on, lift off, rolling on, roll off surfaces. The container is built in lifting on, stacking, casting on all fours, corners, engineered with the sand. The stress on the lift of the lifting operations is port rail terminals and loading docks, the corner posts, construction permits, stacking the full loaded containers. These features design constructions are particularly desirable for ship operation where the crane is on a practical meeting, so landing and unloading containers. Some of the containers have four pockets that they enable to be loaded and unloaded by the forklift trucks. Pulling a container on and off the railway car is done by the power operator that provides the power to draw the container on and off the car. The container is locked on the rail car by the same kind of tie-down clamps used in the secure ordinarily truck trailers. A trailer and chassis designed and built to accommodate the container. The trailer chassis has devices that lock and unlock the container easily and quickly. The chassis is moved by the truck tractor that operates dependently on either rough country roads or smooth city streets. The chassis is equipped by the piggyback adapter equipment so that they can be driven off or off the piggyback rail car. From front to rear, the engineered built for the container services. The piggyback rail car designed exclusively for the container piggyback services. The piggyback railway car is equipped with a shock absorber. They absorb 75% of the shock of the car, receives the center rate guide, and they automatically aligns the counter containers trailers so that the loading unloading is smooth, continuous, hands-off operation. Automatically tie down hitch that operated from the truck tractor, which is backed onto the railway car, so secures trailer, contains or shock absorbing mechanism because the load is carried lower than the ordinary railway cars. This piggyback car provides railway car clearance for the largest trailers normally in use. Provision is also made by possible future changes in the width of the trailer because there are no side rails to interfere. Mixed loads of containers, conventional trailers can be hauled in piggyback railway cars without modification and can transport containers, chassis with and without containers, and tank trailers, semi-trailers, furniture vans, automotive carriers. This car is fully a capability with ordinary flat cars, both mainline and yard service as present in Military Traffic Management Command. MTMC lease of limited quantity of the equipment was needed for use in domestic interchange. The equipment is now part of the Army's Foreign Service fleet. 223. The Foreign Service Fleet contains the special freight cars, the 88-ton and the depressed center flat cars for carrying very large, very heavy ordnance engineering equipment. And the fleet are ice cold, fiberglass insulated refrigerator cars carrying perishable items. The cranes and snow handle equipment heat up various jobs to keep the railroads operational. The only passenger equipment included in the fleet is 4 cars, service ambulance trains, which consist of three types of cars: a ward, medical personnel, kitchen, dining, storage car. A prototype of each of these type three cars have been designed, built, standard to broad gauge rails. These are now storing ward containing facilities of patient car comforter including an air conditioning system. Sleeping quarters, dressing rooms, toilet facilities are included in the medical personnel. Kitchening storage cars containing a kitchen with a facility to prepare complete and dining areas where meals to be served. A cleaning storage area contains a servicing space for storing supplies. Special equipment in the Foreign Service Fleet are cranes, snowplows. Cranes are in help in handling heavy equipment, and the snow handling equipment cleans the ice and snow from the tracks. In addition, with the use of during the winter months, this machine is also called the spread ditcher car. It can be used during the other seasons for of the year for various track maintenance jobs. Finally, the MTMC lease of limited quantity of rail equipment designed to both container piggyback services for use in the United States because of its greater shock absorbing capability. The equipment may be very effective for transportation highly sensitive weaponry. With this equipment, however, is not presently a part of the Foreign Service Fleet. Chapter 3, General.